Hi, my name is Matt Wilchek, and my teammates are Alex Tsai and Kristen Bradley, and we'll be talking about our attack reproduction on the attack that came from the paper An Object Detection-Based Solver for Google's Image reCAPTCHA version 2, first presented in Ray 2020. So we'll go through how the attack works, how it's discovered, how it was disclosed, dangers it poses, implementation and challenges we all face. Kristen's going to walk through us the awesome demo, and then we're going to conclude with lessons learned on security and potential defenses against the attack from Alex. So how the attack works. A user or bot can navigate to a website that requires human verification using Google's reCAPTCHA version 2. The CAPTCHA looks something similar to figure 1 on the right, where the CAPTCHA asks a human user to select blocks of images matching a description. The attacker or bot would then execute an attacked script that parses the HTML tags of the website. Once the reCAPTCHA blocks are parsed, it'll pull out the label as well, asked to the user to verify. And then a pre-trained AI classification model is then used to predict each image and return the resulting predicted label. Finally, the attack script then selects the images that match the predicted label with the label that was prompted to the user, similar to figure 3 on the right. The CAPTCHA prompts the user to select images of a bus, and then only 3 of the images are automatically selected that match the label of bus from the AI model. So the attack was first discovered with researchers first proposing an object detection model to be used for image selection CAPTCHAs in an IEEE paper in 2016 called I Am Robot, Deep Learning to Break Semantic Image CAPTCHAs. And the research stemmed from the original concept of breaking CAPTCHAs requiring characters and or numbers. In the paper, the researchers leveraged semantic annotations that are automatically generated from an object detection model in order to verify the image with the CAPTCHA prompt. So for example, in table 2, the image of a wine in a glass is prompted using various semantic models like the ones listed. We can see that the annotation is made to describe it automatically. Now, fast forward 4 more years, the Google reCAPTCHA version 2 remains to be a very popular CAPTCHA used for many websites even today. And at this time, the famous object detection model, You Only Look Once, or YOLO, continues to be refined and used in so many different research and industry applications. So for this paper, we chose to model our attack after the researchers only used YOLO version 3 and compared additional object detection models such as Faster RCNN, SSD, and RetinaNet.
Now we move on to how this type of attack was disclosed. One of the first machine learning-based attacks on reCAPTCHA was disclosed in May 2012 at the Hell 1 Hacker Conference. The group DC949 presented an automated attack on the audio version of Google's reCAPTCHA with an accuracy rate of 99.1%. The DC949 group utilized machine learning to analyze many reCAPTCHA audio examples and produce a viable model. Machine learning-based attacks on other types of reCAPTCHA, such as reCAPTCHAs based on numbers and letters, were also disclosed later in 2012. So, what dangers does this attack pose? One potential danger is related to authentication. If bad actors want to automate attacking user accounts, reCAPTCHA may not be able to stop them. Bad actors may also use bots to commit fraud or abuse on websites such as Facebook Marketplace or eBay. Since this type of attack is relatively accessible, reCAPTCHA may not be enough to stop those bots.
So through the implementation, we really need to reproduce this attack. We need to come up with 3 core components. First, we needed a pre-trained AI classification model capable of predicting images from the CAPTCHA. That was my part. Second, we needed a website where we can all navigate to with a Google reCAPTCHA version 2 and practice the attack on. Alex handled that part. And then finally, we needed an attack script that could parse the HTML on the website, use the AI model file, and select the correct images on the CAPTCHA to bypass it automatically, which was handled by Kristen. So for my challenges, I had a lot of trouble researching a good enough data set that had the potential images that would be prompted by Google reCAPTCHA. Luckily, I found the public data set on Kaggle, which is a very popular data science website for public data sets. The data set had the images we need. Unfortunately, there wasn't an equal distribution of all the possible labels. So I also needed time to develop an algorithm to train the actual physical model file that Kristen would then use to perform the attack. The paper that proposed the attack used only YOLO version 3. And I ended up going with YOLO version 5 and tried a YOLO version 8, which was the most advanced YOLO model to date. And then finally, I was only able to get a YOLO v5 model file to work successfully for the attack reproduction in time for the project.
The main tools used to perform this portion of the attack are Selenium WebDriver and Torch. Selenium is a testing automation tool that allows you to automate browser interactions, such as navigating, downloading, and form filling. We use Selenium in this case to download images for processing and click the images that our model deems correct. Torch is a scientific computing framework with a machine learning library based on Lua. We use Torch to load our model for image processing and use the results to determine what Selenium should click. Both of these tools are free and open source. One challenge surrounded the key phrases required to get Selenium to click the correct places. The key phrases we check to determine whether or not we have completed the reCAPTCHA are always present once the CAPTCHA has been loaded. This led to the script attempting to click buttons that did not exist and therefore caused crashes. Our solution for this issue is to check the current style setting for these key phrases.
Implementation part. First, we use the Flask, which is a lightweight and flexible web application framework written in Python. This framework allows you to quickly build a web application without the overhead of a full-stack framework. Another great feature of that is it has a built-in development server. This server allows you to quickly test and debug your application locally before deploying into the product environment. Another tool we use is NGRoll. NGRoll is a useful tool when you are developing or testing your web application locally and want to expose it to the internet. Without having to deploy it into the remote server, NGRoll can help you to create a secure tunnel that forwards the traffic from a public endpoint to your local machine, so that anyone can access your web service from anywhere in the world. Finally, we're using the reCAPTCHA version 2. reCAPTCHA version 2 is an effective solution for preventing bots from accessing the website and protecting against the spam and abuse. Its advanced techniques can challenge ease the implementation and simple user experience, make it a valuable tool for website owners looking to enhance their security.
To begin our attack, we first run our Python script in which Torch loads our model. Selenium then boots up Google Chrome and clicks the reCAPTCHA box. Selenium grabs the CAPTCHA category and proceeds to download the images. Then, in the background, Torch has our model process the images and make its predictions. Currently, the model is analyzing the photos and attaching prediction labels to them. Selenium then uses those predictions to click the correct images. Then Selenium will click verify and the reCAPTCHA v2 will have been defeated. And this concludes our demo.
Let's talk about the lesson learned on the security side. reCAPTCHA has several pros and cons to consider. On the pro side, it's resistant to basic malicious attacks such as DDoS, brute force. The challenge presented by the reCAPTCHA can also have a deterrent effect on hackers, making them less likely to attempt malicious activity. Additionally, the advanced risk analysis technique used by the reCAPTCHA can increase the chance of catching the malicious user and preventing the fraudulent activities. However, there are also some cons to consider. While reCAPTCHA is effective against the basic attackers, however, there are ways for more sophisticated attackers to bypass the defense. This can leave a website vulnerable to more advanced threats. Additionally, the challenge presented by the reCAPTCHA may be difficult for a user with disability to accomplish, which can lead to its usability issues and potential legal concern. Let's talk about the potential defense strategies. Web activity tracking is a technique used to detect bots from humans on websites. It involves analyzing user behaviors such as mouse movement, click, and typing pattern. So this is effectively can distinguish by using the machine learning method. We can just distinguish whether this is a bot or human actions. Second way is include more type of challenge. So the challenge may be adding more challenge like a puzzle or image recognition task. In addition to tracking the user behavior, this can make it more difficult for a bot to bypass the challenge and access the website. Another approach is to randomize the challenge time duration. So the bots cannot predict when the challenge will appear. They only can fix the timing to answer any problem. This can further enhance the security of the website and prevent the bots from using atomic script to bypass the challenges. We can also consider upgrading to the reCAPTCHA version 3, which uses a risk-based approach to detect bots and humans. This version reCAPTCHA does not require user to complete the challenge, but instead use a scoring system to determine the likelihood of a user being bot or human.